All right, so here we go. Let's take a quick look at this. Areas of similar figures. So remember, going back, they are similar figures because why? Angles are what?
Equal.
Congruent, and their sides are what?
Proportional.
Proportional. Sides are proportional. All right. So can anybody tell me what the area of the shaded triangle will be in number 1? What?
80.
80. Wrong. That'd be way too easy. Anybody else?
1,750.
Why do you think that?
44 times 80. Oh shoot, my bad. I thought that was wrong.
It's all right. What is it?
640.
Why 640?
Because you divide, you multiply 20 by 2, divide by 11, multiply by 4, and multiply by 3.
Okay, so she's doing the practical ways, just figuring out what the height is, right? And then the base. But we don't know it's a right triangle. Is that a problem? Because really, we don't know what the base and the height are on this. Does everybody agree? All right, so now let's look. The area of a triangle is 1/2 base times height. Does everybody agree? Now again, all I'm doing is I'm just showing you why this works. All right. So does everybody agree these are proportional? Right. So if B is the base of this triangle, what would the base of this triangle be? Say it again. 4B. You guys are great. So what's the height of the shaded triangle going to be? 4H. Does everybody see that? So then the area is going to be what? 1/2 what? 1/2 16BH. That is correct. So now can someone tell me what the area of the shaded triangle is going to be? Say it. I'm asking, so you just said the area of this is 1/16. 160. All right, I'm sorry, I can't hear it anymore. Does anybody agree with 160? 80? Somebody else? Oh, come on. You guys did good on this. So someone tell me, what does that mean about this area compared to this area? It's what? Charlie, what? It's just 16 times greater. That's it. Why is it 16 times greater, not 8? No, because you're looking at these. Okay, yes, you're right. Sorry. You're looking at these formulas. This formula is 1/2 base times height, and this is 1/2 16 base times height. So it is what? 16 times larger. So I agree with that. So this is just what? 320. All right, tell me.
So I thought it would be so 20 is base times height of the smaller one. So
You mean 1/2 base times height?
5.
You mean 1/2 base times height? Oh, okay. You know what, Sam? That's I like your thought process. So look right here. Does everybody understand? 1/2 base times height equals 20 here, right? Come on now, look up. Come on, because again, every year I say this is so simple, and every year kids don't understand what I'm saying. So what does 1/2 BH equal? Look, 1/2 BH. I'm going to move out of the way. And what am I going to replace with that? 20. 20 times 4 times 4. 320. That's actually the first, that's a pretty cool way of thinking about it. All right, does everybody see that? Everybody agrees 1/2 base times height equals 20, right? Now, I'm just going to reverse here so I can show you something. Now, does everybody understand this base over here and this height is the same as this base and this height? Right, it's just 4 times larger, correct? All right, so let's see if I made any. Number 2 is a little bit harder. All right, so now what I want to do is, can anybody see a relationship with the numbers and how I figured out this right here was 320? So the ratio of the sides would be base to height, right? And that was, it was 4 times larger. So why was the area 16 times larger? Tell me. Yeah, and again, I just don't understand why that's a difficult thing to understand. The base is what? 4 times larger, and the height is 4 times larger. So that means that the area is what? 16 times larger. Now, another way to think of it is this. If the ratio is A to B, right? This is the ratio of the sides. Then the ratio of the areas is going to be A squared to B squared. Now, what does that mean? The ratio of the sides is 4 to 1, correct? Now, look what happens. Square 4, square 1, 16 to 1, right? That means that the areas are what? 16 times greater. Is everybody with me on that? All righty. So let's see how good I did. Now, again, I'm going to give you a chance. All right, I want everybody to knock this out for me and tell me what the area of the shaded rectangle is. What's the area of the shaded rectangle? Use your calculator if you need to. Go. 3.765, somebody said. I have no idea if that's correct. Somebody else, tell me. Come on, get your handy dandy calculator out. Let's get to work. Tell me. What is it? Somebody said 8. What? 8. What? Come on, the rest of everybody. All right, Brady, how do we do that? So the first thing we did was we did 8.5 divided by 2, which is 4.25. And then what did I do? No, that's definitely not right. Tell us.
So I took that 8.5 and I did A equals 1/2 B 8.5 B.
Well, I'm miserable. Sorry. Go, Karina. Shh, listen to Karina. She's always right. Hold on, I was interrupting you. You didn't hear me say you're always right. So go ahead. Thank you. Wow. What does that answer? That's what I'm saying. Come on now. 1.882. Like I said, guys, for me, personally, Karina, does that make sense to you? I mean, guys, I don't want you to think that that doesn't make sense. That's what I'm trying to get across. There are so many ways to think about this problem. You just need to find a way to say, All right, this makes sense to me. And do it however you want to do it on your calculator. Personally, I think 8.5 divided by 2 is perfect. That means that the rectangle is 4.25 times greater than the small rectangle, correct? So if I square that, everybody put 4.25 on your calculator and square it. Now, please listen. That means, Karina, the area of the large rectangle is what? No. I want Karina. Tell me. No. The area of the larger rectangle is how many times greater than the smaller rectangle? Sam, tell me. Yeah, guys, I don't understand that. The larger rectangle is 18 point yada, yada, yada times greater than the smaller rectangle. Does everybody agree with that? Now, all you have to do is say, man, I'm sorry, I'm not getting it. Anybody have any issues? What? Shh. I'm listening. I'm not asking that. Listen, can you do, you sure? You positive? All right, what? No. I'm not asking that. I'm asking, does everybody understand 8.5 divided by 2 is 4.25? That means each side of the rectangle of the large rectangle is 4.25 times greater than the other corresponding side. Is everybody with me? Does everybody understand that? So now, if each side is 4.25 times greater, 4.25 times 4.25 is that number, Karina said, which means that the area of the larger rectangle is 16 or whatever, 18 or whatever number you said times greater than the smaller one. Does everybody understand that? Sam, you're looking puzzled. You understand that? All right. So now I never understood kids' problem with this. So I'm going from the area of the large to the small. So it should be what? The area of the small rectangle should be larger or smaller? Smaller. So am I going to multiply or divide? I'm going to divide. So it's 34 divided by whatever 4.25 squared is. I just think that is super simple. And again, I think it's simple. Kids do not think that's simple for some reason. Anybody have any issues with that? Everybody okay with that question? Because obviously I'm going to find out because we're going to do the next one. All right, and I want everybody to tell me the answer for the next one. All right, so here we go. Come on, guys. Let's check out number 3. Since no one has any questions now with 1 or 2. All right, let's knock out number 3. All right, I'll give you a second now. And then when you think you know what the side is, feel free, raise your hand, and then I'm going to ask you, oh, wow, before I even get through with my question, Mia, thank you. What is the length of the side of the small pentagon? Somebody said 7. I'm not sure if that's correct. What? 3. I got a 7. I got a 3. Charlie, tell them. 7. Wait a minute. Davis can't be wrong. That hasn't happened. Yeah. But you just misread your calculator. I got you. 7 also. All right. Tell me again, how easy is this problem? Go. Shh. Whoa. What is that number? 9. Why do we do the square root? Right. This is the ratio of the area. The ratio of the area is a squared to b squared. So that ratio is 9 times greater. So if the area is 9 times greater, that means the side is? The side, if it's 9 times greater, that means the side is how many times greater? 3 times greater, right? Now, I can't tell you how many people put 63 down, right? You just have to be careful. You just have to be careful. So again, I just think that is easy. But for whatever reason, I can't tell you how many kids just struggle with this concept. All right, now, everyone is telling me you're okay with that being 7. Tell me. Yeah, you got your calculator handy. So what is the ratio of the areas? Well, that's what you're telling me. Are you asking me is it 9? Or are you telling me it's 9? So here's the area of the large. This is the area of the small. How many times bigger is the area of the large pentagon than the small one? Why? Exactly, exactly. So the ratio of the area is 9 times larger. So that means the ratio of the sides has to be, no, the ratio of the area is 9. So the ratio of the sides would be what? Look right here. Look right here. This is the key to everything right here. If I have the ratio of the sides, it's A to B, right? To find the ratio of the areas, I'm just squaring. So if I have the ratio of the areas, how do I find the sides? That's it. All right, so what's the square root of 9? 3. So that means that the large pentagon, the sides are 3 times as large as the smaller one. You agree? And so now we have 21, and we're moving 21 to the smaller, so I know I divide. All right, that's how I look at it. Am I getting larger or am I getting smaller? All right, if I'm getting larger, I multiply. If it gets smaller, I'm dividing. All right, so see how great we are. All right, number 4, pretty good mental math here. All right, somebody says 2. Come on now. If you don't know it's 2, this is your time to put your hand up and say, come on, give me a little help here. Ruffin, is that you? All right, what's the ratio of the areas, please? Right, 36 to 1. So that's the ratio of the areas. So what's the ratio of the sides? Shh, don't tell him. Right. So the ratio of the sides are 6 to 1. So if this is 12, this has to be what? That's simple, right now? All right, here we go. All right, number 5. Somebody already is telling me 4.51 inches. Not sure if I'm going with that. Now, turn that back to a fraction, please. Does it go to a fraction? I don't like 4.51. Is it exactly 4.51? Is it exactly 4.51? If it's not exactly 4.51, I don't want the answer. I want it as a fraction. What was the fraction? Nothing. Oh, that must have mean that it was an irrational. If it can't write it as a fraction, that means it's irrational. All right. So I want someone to tell me what's 71 divided by 16. Oh, just 71 divided by 16 because it doesn't go evenly, correct? So when you take the square root, it's actually the square root of 71 over 4. Come on, think about that. That's just good math right there. Does everybody agree with that? That's why it wouldn't allow you to convert it, right? So it's the square root of 71 over 4. So basically, it's just 9.5 divided by that. Now, 9.5, do you agree, is the same as 19 over 2? Everybody okay with that? And then I'm dividing that by square root of 71 over 4. That's what you did, I'm sure. What? 9.5 is a fraction, right? So again, watch this, guys, just to make sure. Come on. 19 over 2 times 4 over radical 71. 9 times, or that goes in twice. So 38 over the square root of 71. Now everybody do 38 divided by the square root of 71. Tell me if that's 4.51. And then on your SATs, they might say 38 radical 71 over 71. But again, I'm just reviewing with you those square roots. But again, 4.51 is perfectly fine. All right, easy. All right, let's check out number 6. You guys are going too fast for me now. All right. All right, so somebody said x equals how many feet? Anybody else with 9.522? Now, can you do the smaller divided by the larger? Yeah, you can do small divided by large. Doesn't matter. I just don't do it that way because I think the number is easier if you have the large over the small. So what was 588 divided by 272? 2.16. Hit math, enter, enter. Tell me the fraction that is. Over 68. Yeah, that's kind of ugly number. So then you take the square root of that, and then you divide it by 14, and that gives you x. Everybody happy with that? That's easy. All right, let's do number 7. Say it again. You got a question? Then you do 14 divided by that answer. Right? All right, help me out with 7. Matt has 2 posters for a science project. Each poster is a rectangle. The length of the larger poster is 11. The length of the smaller is 6. What's the area of the smaller poster if the larger is 93.5? Come on, figure that out, please. What is it, Kenzie? Inches squared. Anybody else get that? You got it? 27.81 square inches. Anybody have any issues with that? What? Well, I just did 11 divided by 6. Do 11 divided by 6 on your calculator. And then square it. The larger poster is 93.5, so I just take 93.5 and divide it by that answer. Come on, right? Anybody else? Anybody else? Anybody else? Everybody's agreeing it's 27.81? Okay, that's what I'm saying, guys. Don't sit there with a number on your calculator that's different. Don't tell me. You might be right. You might surprise yourself. Does anybody need me to do that problem? Who said yes? All right, so first thing, 11 divided by 6. And then hit the square button. That's the ratio of the areas now. You agree with that? That's a good mistake. Anybody else need me to help with the calculator? Anybody else? Watson, you good? Birthday girl? Anybody else? Nothing. All right, let's come down here to some of these SAT problems. Number 1, the polygon has an area of 225 square meters. If the area is tripled, If the area is tripled, how does each side change? Tell us.
Each side is multiplied by 9.
Tell him. That is exactly correct. Square root of 3, which is 1.71. Do you agree with that? It's saying that the area is tripled. It's not saying the sides are tripled. That's what I'm trying to tell you. If they give you the area, the ratio of the area is a squared to b squared. And if a squared to b squared is 3, that means the square root of 3 would be how it's affecting the sides. Agreed now? All right, here we go. Everybody take a look at number 2. Smith's Bakery is baking several large cakes for a community festival. The cake consists of 2 geometrically similar shapes as shown. If 50 pieces of cake can be cut from the smaller cake, how many pieces of the smaller size can be cut from the large cake? Uh-oh. Hold on a second. I got kicked out. Okay, for whatever reason, I'm having trouble. Just stay with me. What do you think? Somebody said 125. What did you say, Brady? 312.5. Okay, so let me ask you this question. Are these similar? Right? Did you do 5 divided by 2 and 4 divided by 1.6? They both equal 2.5, right? So this large cake is 2.5 times the smaller cake, right? So that means if 50 pieces of cake can be cut from the smaller cake, right? If you have 50, right? This cake over here is how many times bigger? Somebody tell me. How much? The area. How much more area though? So there's 6.25 more area. Do you agree? So then wouldn't it just be 50 times 6.25? 312.5. All right, now, again, guys, come on now. Don't sit here and not know that. All right, some of you I can see are a little shocked. Go. Each, you with me? The side is the large cake is 2.5 times the smaller. You agree with me? So is that helpful? So then if you can cut 50 pieces from the small cake, multiply it by 6.25, and that will tell you how many you can get from the large. Ruffin, is that good for you? All right. Let's see if we can do number 3. So Carla had a shirt with decorative pins in the shape of equilateral triangles. The pins come in 2 sizes. The large pin has a side that is 3 times longer than the small pin. If the area of the small pin is 6.9, what is the approximate area of the large pin? That's no problem at all. Somebody, quickly. How much? What? Because I'm not sure what you're doing. 62.1 centimeters squared. Okay, you're supposed to be getting better. What? Well, how many times bigger is the large triangle than the small triangle? So then the area would be how many times bigger? 9. The small pen has an area of 6.9. So do 6.9 times 9. You're with me now, right? Again, keep trying. All right? Keep trying. Hopefully you'll see it. Let's do another one real quick. All right, just to make sure. One last shot here, number 4. Oh yeah, this is a good one too. I like this one. I'm glad we're doing it. Somebody said $6,250. I'm not sure if that's correct. Is that right? You got it? 7,250. 6,250. What? Okay, so what we want to do again is we're looking at this. And again, honestly, guys, believe it or not, this is how you can calculate the costs of things. All right? So what is the ratio of the large to the small? 2.5, right? So now square it, that's what? So it's 6.25 times greater, correct? So that means the cost is going to be what? 6.25 times greater. You with me? Okay. 6,250. What? Oh, hold on. She might be right. How much should the town budget for the cement for both fountains? You're correct. So 6,250 for the large, 1,000 for the small, so 7,250 altogether. Thank you very much. All right.
No, I'm not. I'm here.
All right, here we go. Last one, number 5. Come on, let's go. Let's go. Get it. Last chance before I turn you loose. We have a problem, right? Well, it's a what shape? All right, so here we go. Let's try to draw an octagon so I can show you. All right. So try to draw yourself an octagon. Yeah, all right. Now, with a regular octagon, what's the central angle going to be? Thank you, whoever said that. How much? 45 degrees. Thank you, Charlie. 45 degrees. All right, so how many triangles are there going to be? 8. So area equals 8 times 1/2 base times height. What's the base? The base is 7. So I have 8 times 1/2 times 7. Now I have to figure out the height. So take the triangle. The angle is cut to what? 22.5, correct. And now you're trying to find the height. Now what happens to the side that's 7? What do we do with that? It becomes 3.5. Thank you very much. So in order to find the height, what trig function do I need? What's the trig function I'm going to use? Tangent. So I want everybody to write down tangent 22.5 is equal to, now what would the ratio be? Thank you, 3.5 over h. So now when you cross multiply and divide, you get h is equal to 3.5 divided by tangent of 22.5. plus 45 divided by 2. When you draw the height, it bisects the angle. So the central angle was 45. Now it's 22.5. What? That's okay. Yeah, the tangent of 22.5 is equal to 3.5 over h. All right, tangent 22.5 is equal to 3.5 over h. So h is equal to 3.5 divided by the tangent of 22.5. Somebody tell me what h is. 8.4. Okay, so now we know the height. And now, what is the side length of the smaller? All right, so now we have to figure out what the area is. We have to figure out what the area is. So the area of the large octagon would be 8 times 1/2 times 7 times that number 8.4. So that area is what? How much? 200. What are you guys getting?
236.59.
Anybody else getting 236.59 or something close to that?
Yeah.
Right. So now that's the area of the large octagon. What's the area of the small octagon? 19.28. So now take that number on your calculator and divide that by 19.28. And somebody tell me what that is. 12.27. So that's the ratio of the areas. So what's the ratio of the sides? 3 point what? About 3.503, right? So now the length of the larger is 7. That means the length of the smaller is roughly what? Roughly 2, right? Roughly 2. All right, I'm happy with that right now. All right, so now what I want you to do is I want you to try the middle worksheet real quick. All right, try the middle worksheet. All right. Now I'm gonna reset the Apple TV. All right, and then if you need to see my notes, I'll be happy to show you.